Alright, so here we are. We're going to do, starting now, something new that's hopefully helpful. We're going to talk about section 5.5b. We're going to do section 5.5b right there. Section 5.5b is the addition of polynomials. So section 5.5 kind of talks about polynomials. This part of 5.5 is going to talk about addition of polynomials. Let's see if I can do this. Awesome. Alright, so now what we're going to do is we're going to talk about addition of polynomials. So here we're talking about addition of polynomials, section 5.5a. The first one is kind of the hard one because we had to talk about terms. Remember, terms are separated by addition. We had to talk about coefficients, leading terms, leading coefficients, things like that. If you need a little refresher on that, on all those terminology points, go back to that video. We'll kind of refresh our memory as we go through some of these. I'll give you some, some hints, reminders about things. So that said, we're going to talk about addition of polynomials. Remember, polynomials could be monomials, binomials, trinomials. Monomials have just one term in them. Binomials have two. Trinomials have three terms. Terms are separated by addition. So if we're going to add like terms, we have to determine what the terms are. Terms are things that are separated by addition in a polynomial. So we need to refresh our memory too about like terms, because when we add polynomials, adding polynomials essentially means adding like terms. So we need to remember what like terms are. Terms are things that are separated by addition. Like terms means that they have exactly the same variables and exactly the same exponents. That's going to be really important. So let's take some examples. Let's take 3xy and 4xy. Can we add those? Well, let's take a step back and say, are they like terms? If they're like terms, then we can add them or subtract them later on. In fact, later on we're going to be talking about subtraction, but right now we're going to talk about like terms and adding them. Like terms have exactly the same variables, exactly the same exponents. This has an x and there's an x. This has a y, there's a y. Exactly the same variables, exactly the same exponents. X to the first, x to the first, y to the first, y to the first. Awesome. These have exactly the same exponents to exactly the same exactly the same variables and exactly the same exponents on those variables, so they are like terms and we could add them up. Unlike terms would be something like this. Here's a 5xy and a 6xy squared. Remember, like terms have exactly the same variables, exactly the same exponents on those variables. Here's an x, we got an x. X to the first power, x to the first power. Sounds great. Do we have a y? I've got a y over here, but over here I've got y squared. So this means that these are not like terms. These are unlike terms. We cannot add them or subtract them. They are unlike terms, so we can't add them or subtract them because of that y squared term. So, like terms have exactly the same variables, exactly the same exponents. That'll be important. That'll be, let's see, how about a take-home message for that? That might be something to remember. Like terms have exactly the same variables, exactly the same exponents. That said, let's take a look at adding like terms. If we add like terms, what we can do is we can say that if I've got 3x, in fact, let's take a look at this. 3x plus 9x minus 2x. Number one, I guess we want to try and add and subtract them. So if we want to add and subtract terms again are separated by addition or subtraction. We have to say they have to be like terms. Are they like terms? If they're like terms, they have to have exactly the same variables, exactly the same exponents. Here's an x to the first, x to the first, x to the first. These are all like terms because they all have x to the first. So they're like terms, so what we can do with them is kind of do the reverse distributive property and say, well, we can kind of factor out an x here, and we'll talk about factoring, I guess, in the next chapter, but if we say that this is 3x plus 9x minus 2x is the same as 3 plus 9 minus 2, in fact, take the coefficients out. The coefficients are the numbers that are in front of the variables. If we take the coefficients out in front and kind of group them together, and then multiply everything by x, then we have the combination of these like terms, because 3 plus 9 plus minus 2 combines together all the coefficients. So 3 plus 9 is 12, minus 2 is 10, so that gives us 10 times x. That means that these, when we add up those like terms, gives us 10x. 3x plus 9x minus 2x is 3 plus 9 minus 2x, as long as all these x's are the same. X to the first, x to the first, x to the first. If these are like terms, we can do that. Alright, so that said, let's see if we can add these polynomials. Can we add these polynomials? If we add the polynomials, what we're doing is adding like terms. So if we add a polynomial, we add like terms. And keep in mind that when we add polynomials, we're going to talk about real life situations like adding cost factors and revenue factors and adding those all up to get maybe a profit or loss polynomial. So that's kind of our long-term goal, for especially for next semester. But for right now, we're just kind of working on adding polynomials. Can we add these polynomials? Number one, here's A. And remember here we're going to do A, we're going to do B, and I'll give a C question for kind of the homework. So remember to take notes and all this stuff. Pause the video when you have to in just a second, but let's take a look at this. Can we add these polynomials? Here's a polynomial. I'll underline it in green and say, you know what, here's a polynomial. That green one is a polynomial. That polynomial, the green one, happens to be a monomial. This polynomial here happens to be a monomial. Here's a green polynomial that's a monomial. Here's a red polynomial that's a monomial, just one term in each one of them. Can we add up those polynomials? Here's a green polynomial and here's a red polynomial. When we're adding polynomials, really we're adding like terms. So the only terms in each polynomial are just this term and that term, the green term and the red term. Can we add those terms now? We can add the terms if they're like terms. They are like terms if they have exactly the same variables in each of the terms and exactly the same exponents in each of the terms. Let's take a look at these. Do they have exactly the same variables? There's an x and an x, a y and a y. Do they have exactly the same exponents? X squared, y to the first. Yep, those are like terms because they have exactly the same variables to exactly the same powers. So, that said, we can add these up. Just like up here, we just add the coefficients or subtract the coefficients later on if we're going to, in fact, in the next section we're going to talk about subtracting polynomials, but for right now we're adding. So we add up the coefficients. The coefficients are the numbers in front of the variables, so we get 3 plus 5 times the variable x squared y, and what that means is 3 plus 5 is 8 x squared y, and that's our answer because we added up the green polynomial, the red polynomial to get 3 plus 5 is 8. Now it's kind of a long-winded explanation, but that's what we have to think about every time we have to add polynomials. We break that polynomial down into each of the terms, and then we say, can we add them up? So that said, here's a good question. Here's question B. Here's a polynomial, and let's make this one a blue. We'll underline this one in blue. There's my blue polynomial. And we'll underline the other one in black, and just to say that there's my black polynomial. So I've got two polynomials. Can we add them up? Well, let's see, the question is, can we add up the polynomials? Well, we can add polynomials if we can add the like terms. So the question is, here's the blue polynomial. It's a 1, 2, 3. It's a trinomial. Here's the black polynomial. It's a 1, 2, 3 trinomial because it has 3 terms in it. Terms are separated by addition. So can we add them up? Well, can we add them up? If we can add them up, if we can add up like terms. So we have to add like terms which have exactly the same variables and exactly the same exponents. What we have to do is go look through each one of these and say what terms have exactly the same exponents and exactly the same variables. So it kind of begs the question that I put in parentheses here, lines or columns. You can go through here and add these up in lines. For this one we didn't have to worry about it because it's kind of a line here. We can add that one and that one. Here's our line that we can add up. But sometimes you can, and in fact let's go through question B, doing the line addition, and say, well, we can add the polynomials by adding like terms. Let's find the like terms. I've got negative 3c cubed, so I've got to find the c cubes here. There's a c cubed, there's a c cubed. I can say it's this c cubed term. The coefficient on it is going to be negative 3 plus 11. What's negative 3 plus 11? That gives me 8. So that would be 8c cubed. How about c squared? I've got a c squared and a c squared. Great. I can add up this one here and that one there. And we can do it by adding up the coefficients because we got their like terms. C squared is the same as c squared. Exactly the same variables, exactly the same exponents. What's 5 plus 6 is 11 plus 11c squared. And now we'll go back and say I've got a c term here, c to the first power, and this one is a c to the 0th power, or c to the 0, remember, is 1, so that's a c to the 0th power. We can't add those up because they're not like terms. Here's a c to the first power, here's a c to the 0th power. So we just have to leave those alone because they're not going to combine. Here's a minus 7c to the first power. We don't have to write it down, but we have to understand it's here. Here's a plus 3. And we could write it as plus 3c to the 0th power if we want, but c to the 0th power is 1, and we don't have to write multiply by 1, so there's our answer. Can we combine those can we combine these polynomials? We can by adding up like terms. So that's the line method, by just going through with a line and saying here, which one is a c cubed term? There's a c cubed term. How about a c squared term? There's a c squared term. You could just go on and kind of line it. Think about which ones are the c cubes and add them up. The different way to do it is, I'm going to, in fact, erase all this stuff here, just kind of make it a little cleaner and say, you know what, if I started off, oops, oh well, we know the answer. But if I started off with this question and said, you know what, how do I guess, can I add these polynomials? Well, yeah, we add the polynomials by adding the like terms. Here's a c cubed term and a c cubed term. You know what, let's write all the c cubed terms right over here and say, because we had one polynomial and another polynomial and another polynomial and another polynomial that we're adding all up, you might want to add up all the c cubed terms easily. In order to do that, you'd say, let's take the 11c cubed and just write down here plus 11c cubed. And this would be the column method that we're talking about. You'd make columns of each of the terms that are each of the like terms. So this column is the c squared like term column. Do we have any c squared? And I'm going to take a step back and say, because we wrote this down over here, we're going to cross it off over here to make sure that kind of logically we were going through all the terms that we've got. Plus 6c squared term goes in the c squared here column, and that would be plus 6c squared. And then over here we cross that off, and then we say, well, I've got a plus 3, and that's a plus 3c to the 0th power, but c to the 0th power is not really written. Is it a like term with this? Well, no, that's a c to the first power. So we'd have to go over here and say, well, now I'm going to add my plus 3 over here, because this is 3 times c to the 0th power, which is, our column for the c to the 0th power would be right here. Here's our column for c to the first power, and now we just say add up all of our columns. Here's our c to the third power. Negative 3 plus 11 still gives us 8c cubed. Plus 5 plus 6 gives us plus 11c squared. Minus 7c gives us the c term, and plus 3 gives us the plus 3 term. And there's our, again, same answer that we had before over here in black that I unfortunately erased. All right, so that said, summary is, no pun intended either, addition of polynomials means you're adding like terms. Like terms are terms that have exactly the same variables with exactly the same exponents. That said, here's our question that you have to turn in on your homework. Oh, hang on a second. Go up a couple of pages. Hang on a second. All right, here's our question. All right, thank you. Question is, all right, here's your question you got to turn in. Here's your question you got to turn in, sorry. Here's the polynomial in green. 4w squared minus 2x is our first polynomial. We're going to add the polynomial 3w squared plus 4x squared plus 6x. Answer that one for me in green. We're going to add up that polynomial, this binomial in green, and this trinomial in green. Add them up. Remember, adding up polynomials is adding like terms. Show me that you know the answer, add it to my Dropbox, add it to my Dropbox, sorry, no pun intended, and we'll go from there. Bring questions to class.